welcome to 3.2 logarithmic functions and their graphs, and we're going to get right into it here. The first question on your chapter 3 test is going to ask you to state the definition of a logarithm. And this is definitely worth reading, most definitely worth understanding, but not the way I want you to state the definition of a logarithm. So you're going to, of course, you have to write this down to get credit, but you're definitely going to want to have this one written down and committed to memory. We'll come back and we'll talk about log base 5, 7 in a little bit, but this part of a logarithm right here, this is read log base 5 of 7, like f of x. X is the thing we put into our factory that we've talked about before. In this case, we have a log base 5 factory. What's going into it is 7, and what's coming out of it is whatever log base 5 of 7 is. So this part is called the base, and we haven't used this terminology before, but the thing we put into a function is often referred to as the argument. Okay, a little sloppy writing there, excuse me. So this is the base, this is the argument. So here is our definition, and here's how you're going to reply to the first question on the test. A logarithm is the exponent that turns its base into its argument. And that takes a little while for a lot of people to get a hold of, but that really answers all the questions about what logarithms are, how they work, how we work with them in equations, and how we think of them as functions. A logarithm is the exponent that turns the base, in this case 5, into 7. Now what's the exponent that turns 5 into 7? I'm not certain. I know that 5 to the first is 5, and 5 to the second is 25, so it's somewhere between 1 and 2. Let's take a look here. On your calculator, there's other ways to get here, but you can get to log change. Now, we have a log button, but that's just, this is log base 10, and ln is log base e, and e is a number that we're going to talk about quite a bit and is used a whole lot in calculus. But to get to a log base 5 or a log base some other number, I can go alpha, window, and you'll see the calculator, the Texas Instrument people think it's important enough that we should maybe have this one in a shortcut. So here's log base, and there we have it. So now I can put in 5 and put in 7. And yes, here's the deal. We should read this as log base 5 of 7. But we want to think about it as this is the exponent that turns 5 into 7. So what is the exponent that turns 5 into 7? And 1, 2, 3. So if I take 5 and raise it to the 1.209061955, and understand that's just rounded, so my answer might not be 7. I'm really not even certain, but it better be really, really close, and it might actually round to 7. Let's see. 1, 2, 3. Oh, sure enough, wasn't quite, but trust me on this one, it's 7. So an exponent, or a logarithm, is the exponent. This whole thing is the exponent that turns 5 into 7. So this is 1.209061955. Now, if we understand that, and I mean truly understand it, we don't need to know these properties of logarithms. Let's take a look. Log base a of 1, a great way to read it, a terrible way to think of it. This is the exponent that turns a into 1. Well, what exponent turns any number into 1 0 does. So 0 is the exponent that turns a into 1. 0 is the exponent that turns a into 1. What is the exponent that turns a into a? Well, what exponent leaves numbers exactly the same if we raise them to the first? Now, this, once we understand it, this actually causes people problems, but once we understand it, this is sort of like asking somebody, hey, what's 11 times 59 divided by 59? It just kind of undoes things. You'll see what I'm saying. This whole thing here is the exponent that turns a into a to the x. So this whole thing right here, this whole thing is the exponent that turns a into a to the x. Well, what in the world could this be if it turns a into a to the x? This must equal x. And then this last one says, if log base a of x equals log base a of y, then x equals y. And that's because logarithms are one-to-one functions. So if I've got log base 3 of x plus 4 equals log base 3 of 2x minus 5, then what I know is x plus 4 has to equal 2x minus 5. Okay. Then natural log. Natural log is just log base e. It's written as ln, but oftentimes I will go ahead for a lot of times and write it as log base e. I don't honestly for myself do that anymore, but I think when we start off it's nice to just think of it as this is just a special case of this. And we'll say things like log base 5 of 7. So you can write it as, you can take an ln and immediately write it as log base e. I think that helps in learning and understanding. And therefore, what's the exponent that turns some special value e that we'll talk about more? What's an exponent that turns e into 1? 0. What's the exponent that turns e into e? 1. What's the exponent that turns e into e to the x? Well, what would go here must be x, and the same one-to-one property. So there you have it. There's a lot going on with that, probably worth taking another look at. But once we understand that, truly understand it, makes this stuff very, very easy. Okay, there's nothing to solve here. There are no x's, but we're going to change the form of these. Write the logarithmic equation in exponential form. And they give us an example, but watch this. This is the exponent that turns 3 into 81. Forget about the 4 for right now. This is the exponent that turns 3 into 81. So if I put log base 3 of 81 right here, this is true. 3 raised to the exponent, 3 raised to the exponent that turns 3 into 81. 3 to the log base 3 of 81 is going to equal 81. Well, but this is equal to 4, so this is just 3 to the 4th equals 81. This, which is negative 3, is the exponent that turns 10 into 1 on 1,000. This, which is equal to 3/4, so 3/4 is the exponent that turns the base 16 into the argument 8. And this, which is 2/3, 2/3 is the exponent that turns 5 into 3rd root of 25. And that's it. Can that possibly be the case? Let's take a look here. Let's go 5 raised to the 2 divided by 3 is 2.924. And third root of 25. So let's go alpha window here for third root. There's another nice feature. Third root of 25 is that. So there we have it. Okay. Now this is going to be in reverse. But sure, 8 to the second equals 64, and we know it. But 2 is the exponent that turns 8 into 64. 2 is the exponent that turned 8 into 64. This is the exponent, this is 2, that turns 8 into 64. 3/2 is the exponent that turns 9, its base, into 27, the argument of the logarithm. -3 is the exponent that turns 10 into 0.001, log base 10 of 0.001. And I think that's a t. It's definitely an exponent if I'm looking at 21. So we'll call it a t. T is the exponent that turned n into 10. Okay. So takes a little, kind of takes a little marinating, got to soak in just a little bit on some of that. But once we got it down, pretty easy. But you just need to continuously see things like this, and instead of thinking of this as log base 16 of x, think of this as, hey, this is the exponent that turns 16 into x. But when x is 1/4, we get log base 16 of 1/4. So when we don't have an equation, when we just have a term like this, we might want to just say, what is the exponent that turns 16 into 1/4? So 16, what is the exponent that turns 16 into 1/4? 16 to the, let's say, a equals 1/4. I'm going to write both of these as powers of 4. That is 4 to the second to the a, or 4 to the 2a, equals 4 to the -1st. And therefore, if 4 to the 2a equals 4 to the -1st, 2a must equal -1. A must equal -1/2. Or in this case, use the definition of logarithm to evaluate the function. The whole function, not x, is, but the whole function is -1/2. F of x is -1/2, or f of x is -1/2. Put 1/4 in here. What is the exponent that turns 16 into 1/4? -1/2. This one's actually a little more straightforward. Log base 10 of 100,000. Great way to read it, the way we want to think about it, is this whole thing is the exponent that turns 10 into 100,000. What is the exponent that turns 10 into 100,000? Well, let's see, 10 to the first times another 10, 10 to the second, 10 to the third, 10 to the fourth, 10 to the fifth. A is 5. Excuse me there. 10 to the first would be 10, to the second 100, to the third, to the fourth, to the fifth. A is 5. Okay, there you have it. Once you get pretty good at this, this one's going to go fairly quick. This type of problem should go fairly quickly for you, but don't get frustrated with it. You're going to need to ask questions on this. There are going to be some like this that are a little trickier, and probably this is probably the one topic of the year that the learning curve on it for different students is very, very different. But we're all going to get it. So a logarithm is is the exponent that turns its base into its argument, and all the questions about logarithms are really answered once we truly understand that. Okay, but make certain you're asking questions.